The year is 2025. Artificial intelligence is reshaping industries and our daily lives. But this progress comes at a cost. Sustainability is critical for AI's long-term success. We must prioritize sustainable practices to harness AI's power responsibly. The future of AI is linked to the future of our planet. The rapid proliferation of AI systems, while holding immense promise, casts a long shadow on our planet's already strained resources. The energy demands of training and running complex AI models are staggering, often requiring vast data centers that consume enormous amounts of electricity. This energy consumption often translates into significant carbon emissions, exacerbating the climate crisis. Beyond energy consumption, the physical resources required to build and maintain AI infrastructure are also significant. From the mining of rare earth minerals used in computer components to the disposal of electronic waste, the environmental footprint of AI can be substantial. If left unchecked, this trajectory of resource depletion and environmental degradation threatens to undermine the very foundations of a sustainable future. The challenge is not just about mitigating the negative impacts of AI, but also about reimagining its role. Can AI be harnessed to address the environmental challenges it poses? Can we leverage its power to optimize resource consumption, reduce waste, and develop innovative solutions for a more sustainable future? Contrary to what some might believe, sustainability is not a constraint on AI development but a catalyst for innovation. By embedding sustainable practices into the core of AI research and development, we unlock new levels of efficiency that can drive down costs, reduce environmental impact, and unlock novel solutions. Take, for instance, the development of more energy-efficient algorithms. By optimizing algorithms for reduced computational complexity, we can significantly decrease the energy required to train and run AI models. This not only lowers operational costs, but also minimizes the carbon footprint associated with AI. Furthermore, AI can be instrumental in designing more sustainable hardware. By leveraging machine learning algorithms, we can optimize the design of computer chips and other components to reduce material use, improve energy efficiency, and extend the lifespan of hardware. This holistic approach to sustainability, encompassing both software and hardware, can lead to significant environmental gains. The pursuit of sustainability in AI is not merely about doing less harm, it's about doing more good. It's about leveraging the transformative power of AI to create a more sustainable and equitable future for all. Data centers, the beating hearts of our increasingly digital world, are essential to AI development and deployment. Yet, these sprawling facilities, housing vast arrays of servers working tirelessly to process and store data, are also energy-hungry behemoths. Their insatiable appetite for electricity often translates into a significant carbon footprint, making them a focal point in the quest for sustainable AI. The challenge lies in reconciling the growing demand for computational power with the urgent need to reduce our environmental impact. Fortunately, innovative solutions are emerging. Companies are exploring the use of renewable energy sources, such as solar and wind power, to power their data centers. Others are implementing advanced cooling technologies, from natural ventilation to liquid immersion cooling, to reduce energy consumption. The location of data centers also plays a crucial role in their sustainability. By strategically situating data centers in cooler climates or underground, companies can leverage natural cooling to reduce reliance on energy-intensive air conditioning systems. These efforts, driven by a combination of environmental responsibility and economic incentives, are paving the way for a more sustainable future for data centers. Section 5. Green Algorithms. Optimizing for a lighter footprint. The quest for sustainable AI extends beyond the physical infrastructure to the very algorithms that power these systems. Just as we can design buildings to be energy efficient, we can design algorithms to be computationally frugal, minimizing their environmental impact without compromising performance. This emerging field, known as green AI, focuses on developing algorithms that are inherently more efficient, requiring less energy and resources to achieve their tasks. One approach involves designing algorithms with a focus on reducing their computational complexity. By simplifying the underlying mathematical operations or reducing the number of parameters in a model, researchers can create leaner, faster algorithms that consume less energy. Another avenue involves leveraging techniques like transfer learning, where a model trained on one task can be adapted for a new task with significantly less training data, thereby reducing the energy required for retraining. By prioritizing the development and deployment of such green algorithms, we can ensure that AI evolves in a manner that is both powerful and sustainable. Section 6. Corporate responsibility, shaping a sustainable AI landscape. The responsibility for developing and deploying AI sustainably does not fall solely on the shoulders of researchers and engineers. Corporations, with their vast resources and far-reaching influence, have a crucial role to play in shaping a sustainable AI landscape. By adopting ethical guidelines, implementing sustainable practices, and prioritizing transparency, companies can become powerful drivers of positive change. This includes setting ambitious sustainability targets, investing in renewable energy, reducing the environmental impact of their supply chains, and promoting responsible AI development within their organizations. Companies can also leverage their expertise and resources to support research and innovation in sustainable AI, fostering the development of technologies and practices that benefit both business and the environment. Furthermore, companies can act as advocates for sustainable AI, promoting responsible practices within their industries and beyond. By working collaboratively with governments, non-profit organizations, and other stakeholders, corporations can help create a regulatory environment and an industry culture that prioritizes sustainability as a core value in AI development. Section 7. Leading the charge: examples of sustainability in action. Across the globe, a growing number of companies are demonstrating that a commitment to sustainability is not just good ethics, but good business. These pioneers are integrating sustainable practices into their AI operations, proving that innovation and environmental responsibility can go hand in hand. Google, for instance, has pledged to operate its data centers and offices entirely on renewable energy by 2025. The company has also been at the forefront of developing more energy-efficient AI hardware, such as its tensor processing units, which are specifically designed for machine learning workloads. Other companies are leveraging AI to address specific environmental challenges. For example, Microsoft is using AI to monitor deforestation in the Amazon rainforest, providing valuable data to conservationists working to protect this vital ecosystem. These examples highlight the potential for AI to drive positive environmental impact while also delivering business value. Section 8. The price of inaction, a future compromised. The consequences of failing to prioritize sustainability in AI are not merely hypothetical. They are real and potentially catastrophic. As AI systems become more powerful and pervasive, their environmental footprint will only grow. If we continue on our current trajectory, we risk exacerbating the climate crisis, depleting vital resources, and undermining the very foundations of a sustainable future. The increased energy consumption associated with unchecked AI development will lead to higher carbon emissions, accelerating climate change and its devastating consequences. The demand for rare earth minerals and other resources will put further strain on already fragile ecosystems, leading to habitat destruction and biodiversity loss. Moreover, the ethical implications of unsustainable AI are profound. As AI systems become increasingly involved in decision-making processes, from resource allocation to environmental monitoring, biases embedded in these systems could perpetuate or even worsen existing inequalities, disproportionately impacting marginalized communities already bearing the brunt of environmental degradation. Section 9. Conclusion: sustainability, the only path to enduring AI progress. As we venture deeper into the age of artificial intelligence, one thing is clear: sustainability is not an option, but an imperative. It's the only path to ensuring that the transformative potential of AI benefits all of humanity, not just a select few, and that its progress doesn't come at the expense of our planet's health. The task before us is not simply to mitigate the negative impacts of AI, but to fundamentally reimagine its role. We must move beyond viewing sustainability as a constraint and embrace it as a catalyst for innovation, a driver of efficiency, and a source of competitive advantage. The future of AI is inextricably linked to the future of our planet. By embracing sustainability as a core principle, we can unlock the full potential of AI to create a more just, equitable, and thriving world for generations to come. The time for action is now.